Hello and welcome. This is an introduction to the solar system. In this video, we'll have a look at the main parts of the solar system, see how those things interact, then we'll take a trip to visit the planets and moons, see what they actually look like, and find out about their unique and interesting qualities. So before we explore the solar system, let's get ourselves a basic understanding of it, starting with the things in it. The Sun is the largest object at the centre, and everything goes around it. The planets and moons generally all follow the same basic rules. There are exceptions, but if we look down on the solar system so that the Earth has its north pole pointing upwards, planets orbit and rotate in the same anti-clockwise direction, with all their orbits close to being aligned with the Sun's equator. Moons do the same, orbiting their planets and rotating in the same anti-clockwise direction, and virtually every major moon has a locked rotation, meaning one side always faces the planet. There are 8 planets, 4 smaller terrestrial ones which make up the inner solar system, and then 4 giant ones which are in the outer solar system. There are also dwarf planets. They can have moons and rings just like the main planets, but on a much smaller scale. Pluto was thought of as a planet, but since then we found more celestial objects just like Pluto, and in 2006 the International Astronomical Union defined what a planet is. So officially, a planet can only be a planet if it is in orbit around the Sun, it has sufficient mass to assume hydrostatic equilibrium, meaning it's big and heavy enough to become round, and it has cleared the neighbourhood around its orbit. Only the main 8 planets have cleared their orbits, so anything else which orbits the Sun and is big and heavy enough to become round is a dwarf planet. The other 4 official dwarf planets recognised by the International Astronomical Union are Ceres, which lives in the asteroid belt, Haumea, Makemake, and Eris. Yet to be certified are Orcus, Quaoar, Gong, and Sedna, and there could be hundreds more out there. As we look down on the solar system, 2 things are very apparent. Firstly, things take a long time to happen. This is moving in real time, so if we speed it up, and then some more, and some more, and some more, we can see the closer a planet is to the Sun, the faster it moves, and moons do the same around their planets. The other thing about space is, it's big, very big, so ridiculously vast that it's hard for us to get our heads around, because we have nothing to compare it to. So let's look at it like this. Imagine the Sun the same size as a yoga ball. The biggest standard yoga ball you can get at 75 centimeters across. Now picture it on an American football field, right on the edge of the end zone. If this is our scale, then Mercury will be 31 meters away, right here, and it will be 2.6 millimeters across. That's just 1/10 of an inch. That's how big it is, and how far away it is. The Earth will be 80 meters away, and it will be 6.8 millimeters across, just 1/4 of an inch. The largest planet Jupiter, will be 7.5 centimetres across, 3 inches, or the size of a baseball. Still tiny by comparison, and almost 4 football fields away. And the furthest planet, Neptune, will be 1 inch across, and more than 22 football fields away, almost 2.5 kilometres. So far that light takes over 4 hours to get there. In space, things are big and stuff takes ages. Now we've put things into perspective, let's have a look at the Sun. Like virtually all the other lights we see in the sky, it's a star. Technically, it's a G-type main sequencer star, though it's less formally referred to as a yellow dwarf. Yellow because we see it as yellow through our Earth's atmosphere, though it's actually white. And a dwarf because stars out there in the great wide universe can be up to 1,500 times larger across. Just like the planets and moons, the Sun has a rotation and an orbit. It revolves around the centre of our galaxy, the Milky Way, which in the middle has a supermassive black hole. It's about 4 million times heavier than our Sun and 26,600 light years away. Our entire solar system is speeding around its orbit at 250 kilometers every second, but still takes more than 200 million years to go around. Our solar system is 4.6 billion years old. Back before it was born, there was a large molecular cloud in this region of space, which collapsed together to form it. As gravity pulled matter together, it became denser and denser until the central mass became so hot and dense that it eventually initiated nuclear fusion. This is what causes light and heat to radiate from it and provide most of the energy for life on Earth. Every second, it changes 600 million tons of hydrogen into helium, and this process converts 4 million tons of matter into energy every second. The Sun is so massive it contains 99.86% of all the matter in the solar system. The remaining 0.14% became everything else which orbits around it, and now we're going to take a look at it. Our first stop is Mercury. Seeing as it takes light over 3 minutes to get there from the Sun, we'll be borrowing from Star Trek and moving at warp factor 3, which only takes 5 seconds. Here is the first of the terrestrial planets, meaning it has solid ground you can land on. Mercury is the smallest planet. It's only 4,880 kilometers across. There are moons larger than it, but it is the fastest planet, orbiting at 47 kilometers a second and completing 4 laps of the Sun for every 1 of ours. So Mercury orbits the Sun anti-clockwise and rotates the same way. It may take only 88 of our days to go around the Sun, but it takes 58 days to rotate, so you don't even get 2 days in a year. In ancient times, before they were aware of planets, it was thought to be a star. In fact, 2 separate stars, a morning one and an evening one. It cannot appear in the night sky, because when we are looking away from the Sun, we are also looking away from Mercury, and during the day there's too much light from the Sun to see it, so you can only see it in the morning and in the evening. It took the ancient Greeks to figure it out, and they named it Hermes, messenger of the gods for its fleeting appearance. The Romans, who copied the Greek gods, named it Mercury, which was their version of Hermes. There's no real atmosphere around Mercury, it doesn't have any moons, and it's not the most beautiful object out there, though it does resemble our moon. Our next planet is quite the opposite. Now, we visit Venus. When the two planets are closest together, the fictional speed of warp 3 will get us there in only 3 seconds. And we can see how different Venus is. A radiant pearl in the sky. No wonder it was named after the Roman goddess of love and beauty. After the sun and moon, it's the brightest object in our sky. Though like Mercury, it sits between us and the sun, so we can only see it in the morning and evening. And like Mercury, it has no moons. But that is where the similarities end. It takes 224 of our days to orbit. However, a rotation takes even longer, 243 of our days, and it spins very slowly backwards. Venus would have a locked rotation, with one day being the same as a year, but it is forced backwards by the sun's gravity pulling on something that it shares with the Earth, an atmosphere. And the atmosphere is what makes Venus look so beautiful. But before you start thinking we could live there, you should know that this isn't our lovely, breathable nitrogen and oxygen atmosphere. This is a thick carbon dioxide atmosphere with clouds made out of sulfuric acid. If the acid rain wasn't enough to put you off, then you'd find that the atmosphere is so thick and dense that the surface pressure is 92 times greater than Earth's. That would be like diving 950 meters underwater. Military submarines only dive to around 900 meters. The atmosphere is so thick, we're not even looking at the planet's surface. Underneath all of this beauty is a volcanic surface hot enough to melt lead. Venus is the hottest planet of them all. It's heavenly on the outside and hellish underneath. Our next stop is one you will recognise. Earth, the only water world in the solar system. So much water, it covers 70% of the surface. It is the Earth's magnetic field that stops solar winds from stripping away our atmosphere, and our atmosphere captures heat from the sun, allowing steady temperatures and water to exist in a liquid state. The atmosphere also helps to protect us from UV rays which would harm us, and asteroids from crashing into us. The Earth was born some 4.5 billion years ago, along with the Sun. The oceans formed in the first billion, and life first grew in the oceans, the only known life in the universe. We have the densest of all the planets, and the largest of the terrestrial ones. Our orbit is slightly elliptical, so at times we are closer to the Sun, but not enough to notice. Our angle of rotation, however, is quite significant when compared to our orbit. This alters how much we are pointing towards the Sun at different times of the year, and this gives us our seasons, makes it warmer and colder, and the days longer and shorter. Of all the terrestrial planets, Earth has the most significant moon. In fact, it is the largest moon in relation to its planet. It is the 5th biggest overall and has the 2nd highest gravity. So much gravity that it pulls our water, causes the tides, and is very slowly reducing how fast we spin. No one knows for sure how it came to be our moon. It couldn't have formed at the same time because it is 50 million years younger than the Earth. It couldn't have been flung from the Earth because it doesn't contain the same matter, and it couldn't have been captured as it was passing by because our atmosphere would have had to have been too large. Our best guess is that we collided with another, very large object, about the size of Mars. The result of this collision blasted bits into orbit around the Earth, and those bits eventually came together to become the Moon. The Moon has a very limited atmosphere, certainly not enough to protect it from the meteorites which we can see have hit it. Though we only ever see one side of the Moon from Earth because it is tidally locked. It takes 27 days to travel around the Earth, though because we've moved by the time it gets back to its original position, it has to go a bit further from our perspective and takes 29.5 days for a full lunar cycle. It has a slightly elliptical orbit and is 5 degrees off from going around our equator, so it seems to get bigger and twist around as we view it. Now it's time to visit the last of the terrestrial planets, Mars. Mars is about half again further away from the Sun than the Earth is. At its closest to us, it's somewhere in the region of 55 million kilometres away. Mars is a striking planet, visibly red and the only known example of a desert planet. But we're not looking at sand, it's basically rust. Both the ancient Greeks and Sumerians named the planet after a god of war, no doubt influenced by its colour, and the Romans followed suit with their god Mars. There are similarities between Mars and Earth. It has days of 24.5 hours, and its axial tilt is virtually the same. So Mars has seasons just like us. Though its year is almost twice as long, and whilst summer can reach temperatures of about 6 degrees C, its winters get down to -78. Strangest of the features we can see is known as the Martian dichotomy, with the northern hemisphere appearing smooth and flat, whilst the southern hemisphere is covered in peaks and valleys. We don't know why, but it's quite possible that a giant impact melted the southern hemisphere, and when it recrystallised, it formed with a thicker crust. Like Earth, Mars also has water, but it can only exist in the form of ice, and like Earth, that can be found at its north and south poles. There was once an atmosphere here, about 4 billion years ago, and if Mars hadn't lost its magnetic field, maybe there could have also been life. However, Mars is not without activity. As NASA puts it, the only planet we know of inhabited entirely by robots. Since 1979, numerous countries have been sending missions there. Up to the year 2024, 5 spacecraft have flown by it, and 21 missions have successfully managed to orbit around it. 7 of these are still operational. There have been 11 successful landings on Mars, and 3 of them are still functioning today, and for 3 years it even had a helicopter. Mars also has moons, 2 of them, though as major moons go, they're positively tiny. They're called Phobos and Deimos, named after the sons of the god Mars, and they're only a few kilometres across, not nearly enough for their gravities to form them into spherical shape. They're effectively large rocks. Phobos has the closest orbit of any known satellite, and its largest measurement is around 26 kilometres. Curiously, seeing that if you discover things, you get to name them, all of the craters discovered in 2006 are named after things from the book Gulliver's Travels. Deimos is even smaller, with the largest measurement of 16 kilometers and a gravity so low that if you stood on it and jumped off, you'd disappear into space. And that is the last of the terrestrial planets in the inner solar system. Now we explore the outer solar system, where the giant planets live, the first of which is Jupiter. The distances between planets start to get bigger now. The shortest journey to Jupiter will be about 490 million kilometers. At light speed, that would be half an hour, and 42 seconds at warp 3. However, it will only take us 8 seconds because we are now travelling at warp 5. The biggest planet, Jupiter. This still image makes it look like it's made out of marble, but that's not solid ground. This is a gas giant. It's mainly made up of hydrogen. The outer atmosphere we can see is hydrogen in gas form. Then 50 kilometers below that, it forms liquid hydrogen, and as the pressure builds, it becomes metallic hydrogen, and only in the center is a molten rocky core. Jupiter is the fastest rotating planet, moving at 12 kilometers a second at its equator, and the speed affects its shape. If you look closely, you can see that it is fatter than it is tall. Jupiter is also massive, in terms of both size and weight. It is so massive, it's more than 2.5 times heavier than all of the other planets combined. As a gas giant, it's also known as a failed star. The Sun also contains mainly hydrogen, and if Jupiter was 75 times heavier, it could fuse hydrogen into helium and become a star in its own right. It is the biggest and 4th brightest object in our sky. It's the king of the planets, and the ancient Greeks named it after their king of the gods, Zeus. The Romans called it Jupiter after their equivalent. The moons of Jupiter are named after Jupiter and Zeus's descendants, lovers and favourites, and there's a lot of them. 95 known so far, and the 4 largest ones are visible from Earth with binoculars on a clear night. These are known as the Galilean moons, and their discovery by Galileo back in 1610 put us on the path to figuring out that we revolve around the Sun and not the other way around. The inner 3 moons have what is known as an orbital resonance. Io goes around in half the time Europa does, and Europa goes around in half the time Ganymede does. Two of them are regularly next to each other, but never all 3 at the same time. Io is incredibly yellow. There are over 400 active volcanoes here, which makes it the most geologically active object in the solar system, and the sulfur produced gives it this strange colour. In terms of size, it's very similar to Earth's moon, only slightly bigger, and it has the highest density and surface gravity of any moon. Europa has the smoothest surface of any known solid object in the solar system. There's a crust of water ice covering it, which gives it a frosted look. It stands to reason that the largest planet should have the largest moon, and Ganymede is it. At over 5,200 kilometres across, it's bigger than Mercury, though only half as heavy. It is also the only moon to have a substantial magnetic field. Lastly, Callisto, the oldest and most heavily cratered object in the solar system. Four very different moons, and now it's time to visit the second of the two gas giants, Saturn. It's another 535 million kilometres, and for us, a journey of 9 seconds. Saturn, father of Jupiter and the god of wealth and agriculture. The Romans named the 7th day of the week Saturn's Day. It's another failed star and also made of hydrogen. It is not that much smaller than Jupiter, but it's only half as dense, so there's a lot less stuff in there. It's the only planet less dense than water, only 2/3 as dense, and it's the most squashed of all the planets, 10% larger around its equator than the poles. Saturn's surface doesn't have the same patterns as Jupiter. However, there is a very strange hexagonal shape around its north pole. For a sense of scale, each side is about 14,500 kilometres long, and you could fit the Earth into that. Its most incredible feature has to be the extensive ring system. All the giant planets have rings, but this is the only one you can see from Earth with a telescope. The rings are made mostly of ice, helping them to be reflective and visible. From Saturn's surface, they stretch out from 6,600 to 80,000 kilometres, but never more than 1 kilometre thick. Along with the incredibly impressive rings, there are at least 146 moons and numerous moonlets. The first 7 identified were all named after Titans, seeing as Kronos is the Greek equivalent of Saturn, and he was king of the Titans. With the amazing high-definition pictures sent back over 1 billion kilometres to Earth, we can actually see what they look like. So first, we head out for that small moon, and we come to Mimas. Mimas has the second largest crater of any moon when compared to the moon's size. It's so large that scientists are surprised the impact didn't shatter the moon. At about 140 kilometres across, it's a third of Mimas's diameter. But Mimas survived, and now some people think it resembles the Death Star. Next out is Enceladus. Also a smaller moon, at about 500 kilometres across. It's mainly rock covered in fresh, clean ice. There is a large body of water underneath its icy crust, and near the South Pole, cryovolcanoes shoot out water vapour from geysers. Most of the vapour shoots into space, but some falls back down as snow and forms the icy crust, making it one of the most reflective bodies in the solar system. With its global ocean, unique chemistry and internal heat, Enceladus has become a promising lead in our search for worlds where life could exist. Tethys is next, and they're getting bigger now at about 1,000 kilometres across, but it's the least dense of all the major moons in the solar system. Tethys has the largest impact crater when compared to its size. It's named Odysseus, and it's 400 kilometres across. Dione, of similar size to Tethys, is equal parts ice and rock. The The light streaks which can be seen on its surface are ice cliffs. It orbits at about the same distance that the Moon does around the Earth, but takes less than 3 days to go around. Normally, moons are more heavily cratered on their fronts, where they're more likely to hit objects as they travel. But this is the opposite with Dione. It's been theorised that a particularly big impact must have swung Dione around. Rhea is 1,500 kilometres across, which gives it a surface area about the size of Australia. It's a great example of what happens when rocks smash into a bigger rock in space. Titan, as the name suggests, is rather large. It's 5,100 kilometres across, and only just smaller than the largest moon, Ganymede. It is the only moon known to have a dense atmosphere and the only place other than Earth to have stable bodies of water. Its atmosphere has a super-rotation, meaning it rotates faster than the moon itself, and is made up mostly of nitrogen, leading to methane and ethane clouds. Underneath the atmosphere, there's wind and rain and seasonal weather. There are seas and lakes and dunes. The methane cycle bears a striking resemblance to the water cycle on Earth, though very cold at minus 179 degrees C, and has been described as the most Earth-like object in the solar system. It is also the furthest from Earth we've ever landed a space probe. Lastly, we look at Iapetus. It might not break any records, but it does have very strange coloration to it. The front and sides are dark, but the back and poles are bright. Of all Saturn's moons, it is the only one to have an elevated orbit, which means you get a good view of the ring system from it. When moons in space become holiday destinations, this will no doubt be a popular one. And that wraps up the gas giants. From here on in, we're going where only one spacecraft has ever been before. It's time for the ice giants, and our first stop, Uranus. It's twice as far as our last journey, so we'll be stepping up to warp 9 for this one, which only takes 2.5 seconds. Welcome to Uranus, or Uranus, or Uranus, the solar system's butt of many jokes. Some people are embarrassed about it, but it doesn't hurt to have a little fun, and it doesn't mind. It's a planet. It's been said that Uranus is huge, and also that scientists long to probe Uranus. But joking aside, one of the reasons many people fail to learn about it is because of the humour they find in its name. A name which breaks from tradition with planet naming, and for once goes with the Greek god of the sky, not the Roman equivalent, who's called Caelus. The last 2 planets we visited are known as gas giants. Now we're in the realm of the ice giants, and Uranus is the coldest of all the planets. In the upper atmosphere, the temperatures can get down to minus 220 degrees C, and the wind speeds up to 900 kilometers an hour. Along with being the coldest planet, it also has the largest axial tilt. It travels around on its side. In fact, so far over, it technically rotates backwards. It's most likely that 3 or 4 billion years ago, it had a major collision with something bigger than Earth. It takes 84 years to go around the Sun, and in 2033 will only have completed its 3rd orbit since being discovered. The poles spend 42 years in constant light, then 42 in constant darkness. As with all the giant planets, it has a ring system, though it's pretty faint. It reflects only 2% of light and is difficult to see. It also has moons, 27 known so far, and they're named after characters from the works of William Shakespeare and Alexander Pope. Because they're so far out in the solar system, only Voyager 2 has briefly captured them back in 1986, and we don't yet have full images of them or as much knowledge as we'd like. Let's have a quick look at the major ones. Firstly, Miranda. It's 470 kilometers across and similar in surface area to the state of Texas. It has one of the strangest and varied surfaces we've seen, though we can't see all of it. Voyager 2 managed to successfully capture about 50% of it around the South Pole, and has the biggest known cliff in the solar system at 20 kilometers high. Ariel. 35% of Ariel has been captured, well enough for what scientists term geological mapping, and it's quite a young moon, possibly formed from the debris left behind after the giant collision which put Uranus on its side. Umbriel has a really dark surface. It reflects only 16% of the light that strikes it. 40% of it has been captured, and it shows to have had a lot of impacts in its time. Titania, not to be confused with Titan, is the largest of Uranus's moons. Pictures taken show 40% of its surface, and its features have been named after characters and places from William Shakespeare's plays. There are some incredibly long valleys here, up to 1,600 kilometers long, which is the same as the moon's diameter. Oberon is almost as big as Titania, and also has 40% of it mapped. It has a slightly reddish colour, and its surface has been shaped by numerous comets and asteroids hitting it. Uranus was the first planet to be discovered with a telescope. You can't see it with the naked eye, and the ancient cultures weren't aware of it. Its orbit is the most elliptical of all the planets, meaning closer to or further away from the Sun. When it was first observed by scientists, it repeatedly didn't appear where it was supposed to. This led to the thought that yet another planet was changing its orbit. From some very clever mathematics, the position of this hypothetical planet was reckoned by a man named Urbain Le Verrier, and lo and behold, there it was. Johann Gottfried Galle spotted it in almost the exact position it was supposed to be, and that planet is our final stop, Neptune. Neptune, brother of Jupiter, son of Saturn, and god of the sea. It's the furthest planet from the Sun, 30 times further out than the Earth, reaching a mind-boggling 4.5 billion kilometers from the center of the solar system. It has the longest orbit, taking 165 years to go around, and is the densest giant planet. Weather patterns can be seen on its surface, and the wind speeds can reach 2,100 kilometers an hour. That's faster than the speed of sound. It gets below -200 degrees C in its outer atmosphere, but over 5,000 degrees at its centre. Unlike the gas giants Jupiter and Saturn, which are mainly hydrogen and helium, the ice giants have more water, ammonia, and methane. It's been proposed that both Neptune and Uranus could have their methane turned into carbon at their cores, which would result in hailstones made out of diamonds. Neptune has a faint, fragmented ring system and 14 known moons. They're named after Greek water deities, and most of them are tiny. but there's some peculiar activity happening out there. The giant planets normally have lots of large moons, all moving around their planet's equator. But here we see only one large moon. It's not on the equator, and it's going the wrong way. This is Triton, not to be confused with Titan around Saturn. Triton was most likely a dwarf planet which has been captured by Neptune. With its arrival, it's suspected that virtually all of the other moons were smashed into or had their orbits altered, maybe even breaking free from Neptune. There is no other example of this among the planets, and scientists are keen to learn more about it. When another mission to Neptune finally arrives, maybe even landing something on its surface and capturing more than the 40% of it we can see so far. There are now only 2 other sizable moons around Neptune. Proteus is Neptune's next biggest moon, but it's 32 times smaller than Triton. Nereid is quite possibly a moon disrupted by Triton. No pictures exist of it. We don't even know what shape it is. Its orbit is so elliptical, it's more of an oval than a circle that comes in really close and then flings out far away. It may be the last surviving original moon after Triton's arrival, and hopefully one day we'll be able to see what it looks like. So that is all the planets and their main moons, but there's so much more out there. We haven't even talked about the asteroid belts, or Trojans, or comets, or what's outside our solar system. Of course, if you're interested, that shouldn't stop you. All of the things you've seen and heard today are freely available on the internet, plus a whole lot more. One last thing before we go though. If we look up from Earth, we can see a bright star known as Alpha Centauri. It's so bright because it's actually 3 stars. 2 of them, forming a binary star system, as close together as Uranus and the Sun are. If Jupiter had become a star, then we'd be like that. Imagine what strange orbits the planets must do around them. The other star is Proxima Centauri, and it's the closest star to our Sun. Though not that close, it's 40 trillion kilometers away. If we revisit our yoga ball and football field, and the yoga ball is now the solar system up to Neptune, then we will have to cover more than 30 football fields to get there. It's 4.25 light years away. The fastest any space vehicle has left the Earth's atmosphere is 57,600 kilometers per hour. That's almost 1 million meters every minute, 16 kilometers every second. That's very fast, and at that speed you could fly from London to New York in under 6 minutes. However, it would still take 8.5 years to get to Neptune, but to Proxima Centauri, 80,000 years. Space is big, and stuff takes ages. Thank you so much for watching this introduction to the solar system. If you enjoyed it, then the very least you can do is click the like button. Comments, questions, and corrections are all welcome below.